In the search for alien life, finding even a tiny microorganism would be historic. Are they out there? Will we ever make contact? After many years of searching, the game is about to change. New research is revealing surprising possibilities. 200 years ago, we thought about lighting huge rings of fire in the Sahara Desert to signal our presence. And in the 1860s, a French poet proposed a mosaic of giant mirrors, reflecting sunlight onto Mars in the shape of the Ursa Major constellation. But if you want to send a signal across a space ocean, bonfires and reflected sunlight won't help much. Even a nuclear war on a nearby planet would be virtually impossible to detect with current technology. Radio waves are ideal for transmitting information over long distances because, compared to other forms of light, they travel more freely through interstellar gas and dust. The SETI Institute is a collective scientific effort to detect communications or signals from extraterrestrial civilizations. It involves various initiatives and projects that use telescopes and other technologies to try to pick up signals that might indicate the presence of intelligence outside Earth. It does not refer to a single entity, but to an area of research within astronomy and astrobiology that is dedicated to this search. For this reason, the SETI Institute in the search for extraterrestrial intelligence has focused almost entirely on scanning radio signals, whether they are intentional messages or byproducts of technology. Our own radio transmissions have now traveled 100 light years and reached 75 star systems, some of which include potentially habitable planets. And if alien intelligence is beyond this bubble of signals, they could still infer life on Earth by detecting oxygen in our atmosphere. Thanks to the SETI Institute and the Breakthrough Listen project, we now scan tens of millions of stars for signals. But despite all this, after 6 decades of searching, we have only found a series of false alarms and dead-end clues, and we call this the Great Silence. But in reality, the search has only just begun. There are other galaxies out there that are still too far away for practical studies. If space were the size of all the oceans on Earth, we would have searched less than a pool of water for signs of intelligent life. Alien life might consider radio to be a primitive technology. We need to consider all possible alternatives, from the practical to the unimaginable. The search is now on for a different kind of signal, one that we could even detect with the naked eye, such as laser light, which can carry much more data per second than radio. We would have to be in a straight line of sight to detect the beam, but spread over many light years, they would widen to encompass entire planets and moons. Fleets of laser beacons could be used to scan the entire galaxy, but while these bright flashes would be relatively easy to find, advanced life may be using something much more elusive, something with neutrinos, tiny subatomic particles that are passing you by the trillions every second. These ghost particles can pass through entire planets and not touch a single atom. Let's take an example to make it easier to explain. Let's say you're trying to send a secret message to a friend who is on the other side of a very thick wall. If you try to speak or use a flashlight to signal, the wall will block out sound and light. But if you could use something that could pass through the wall unhindered, your message would get through easily. Neutrinos are like this special way of sending messages. They are tiny, almost massless particles that rarely interact with other substances. This means that they can pass through practically anything, walls, mountains, even entire planets, without being stopped or altered. There is an idea that very advanced civilizations could use neutrinos to send messages through space. Since neutrinos can travel great distances, crossing stars, nebulae, and other cosmic obstacles without being blocked, they would be an ideal medium for intergalactic communication. If someone were using neutrinos to send information, these messages could reach anywhere in the universe at practically the speed of light. However, capturing and detecting these neutrinos is extremely challenging due to their elusive nature. It would be necessary to build gigantic detectors, often underground, to have a chance of picking up such subtle signals. That's why, despite being a fascinating idea, using neutrinos for communication is still more of a theoretical concept than a viable practice with current technology. Their messages could be passing through us right now, and we'd have no idea. Or perhaps the alien intelligence is taking a totally different approach to communication, using space-time itself as a medium. In theory, they could manipulate high-gravity objects, creating distortions of space-time patterns, which could spread across the universe in all directions. But creating gravitational waves strong enough to be detectable would be extremely energy-intensive. It turns out that our chances of finding an alien civilization depend a lot on their average survival time. If the average lifespan is something like 100 years, then they will appear and disappear, rarely overlapping, and our chances of finding a living one are slim. But if they survive for thousands of years or more, then our chances will skyrocket as the potential for overlap expands. But what if they're not communicating? Perhaps they find the idea of making contact too dangerous or futile. If that's the case, then we have to be more creative in our search. In 2015, astronomers watched a seemingly normal star begin to dim in erratic waves, unlike anything they had ever seen before. The cause is probably a huge cloud of dust or a shattered moon blocking the light, but it has all the hallmarks of something else, perhaps an alien megastructure. And although this explanation seems unlikely, it suggests a new way of finding intelligent life, not by listening for signals, but by looking for their technology directly. Each alien civilization would be wildly different, but classifying them by energy use will give us insights into what kind of technology they might be using. The Kardashev scale divides them into 3 levels. Type 1, using all the energy available on their planet. Type 2, harnessing all solar energy. Type 3, exotic civilization. But before we go in search of alien super technologies, how do we find civilizations like ours that haven't yet reached Type 1? When a typical planet passes in front of its star, we see the starlight diminish abruptly. But observing a more gradual drop in starlight could be evidence of a dense ring of satellites, a Clark belt. Detecting this kind of light curve wouldn't be incontrovertible proof, but rings around rocky planets are unusual and could point us in the right direction. Just as alien vegetation would leave a biological signature in its atmosphere, alien technology would leave a technological signature. Silicon produces a recognizable light curve, similar to chlorophyll. Detecting this signal could point us to the presence of alien solar cells. Certain pollutants, such as chlorofluorocarbons, are not produced by nature and could be detectable, even in small quantities. These chemicals could even persist long after the death of a civilization, pointing us to the remains of an extinct alien race. Such a discovery could give us crucial guidance on how to avoid our own extinction. And there is another universal danger that we would be familiar with. Any civilization that uses huge amounts of energy will produce large amounts of waste heat. This excess heat could pose a serious threat, just as climate change does for us. But it could also leave a telling sign. Finding residual heat radiating from alien planets or other regions of space could point to intelligent activity. We might think that, if they are not exterminated by their own technology, some life forms could achieve total control over their planet and become a Type 1 civilization. With this dominance would come incredible powers, such as control over all the world's ecosystems, its resources, and even its climate. But no matter how advanced they are, all planetary civilizations will face the same cosmic threats as us. GRBs, gamma-ray bursts, supernovae, star explosions, and asteroid impacts will be risk factors for any terrestrial race. But alien life that decides to remain anchored will need long-term protection, something like a planetary shield. These shields would cause a telltale darkening pattern during transit, and could also emit a detectable heat signature. Large-scale astroengineering like this would require a colossal amount of resources, and the easiest way to get them may not be to mine planets, but to mine asteroids. They are rich in resources and easier to manipulate because of their lower gravity. Scanning distant asteroid fields for temperature or chemical anomalies could indicate alien mining activity. Alien supercivilizations will also need huge amounts of energy. Stars produce billions of times more energy than planets receive. To harness all this, you need to build something truly impressive, something like Dyson spheres, which are megastructures that surround a star, designed to capture all its energy output. Dyson spheres could also be built around black holes, which could have a smaller radius and collect thousands of times more energy. Any being that comes to harness all the energy output of its stars will reach the next level on the Kardashev scale, a Type 2 civilization. This level of mastery would imply an impressive capacity. Star harvesting is the practice of collecting stellar material and could provide resources for thousands of planets. This process would also make it possible to lower the star's temperature, delaying its death by billions of years. In about 1 billion years, our own sun will become too hot for life on Earth. If we ever find evidence of stellar collection, it could inspire us to do the same and prolong the game of life. Eventually, there could be life that outgrows its star and needs even more energy. To branch out across the galaxy, such advanced life forms will probably need to travel at almost the speed of light. It is also possible that alien starships traveling at the speed of light could leave behind a long trail of ionized gas. These trails can emit detectable infrared radiation. Once life forms have mastered all the energy their galaxy can provide, they will achieve unimaginable power, a Type 3 civilization. This cosmic virtuosity would be totally incomprehensible to us. Life that builds billions of Dyson spheres and can create stars at will. In theory, its thirst for energy could make an entire galaxy go dark. So one way to look for Type 3 life forms is to look for what isn't there. In distant space, there are huge voids between galaxy clusters where no light is emitted. These voids were once considered evidence of advanced life, which harnessed the energy of all the stars in the region. But it seems that they occur naturally, and recent analysis of nearby galaxies has revealed no evidence of any civilization on a galactic scale. If such advanced civilizations are out there, perhaps they have chosen to remain invisible. But what if, after all our searching, we never find another sign of intelligence? What if we really are alone? We can never be sure, because there will always be galaxies too far away to study. But never finding any evidence would mean that our place in the universe is truly unique. This would burden us with an immense responsibility to keep the flame of intelligence alive. Just as ancient civilizations speak to us through their monuments, we could build our own monuments or cosmic time capsules, preserving a record of our achievements and knowledge for future life to discover. While we continue to search for giants in the cosmos, the truth is that we still have a lot to explore and discover. If you're as fascinated as we are by the idea of advanced civilizations, alien technologies, and the vastness of space, be sure to subscribe to the channel for more intergalactic adventures. And of course, if you have any theories or thoughts about life outside Earth, share them in the comments. We'd love to hear from you.